You know, inside pretty much every Android phone out there, we're talking billions of them, there's this invisible engine. It's working like crazy to draw everything you see, from the latest game to just scrolling through your home screen. That little powerhouse, that's the GPU, the graphics processing unit. And today, we're going to pull back the curtain and see exactly how this thing works.
All right, here's what we've got on tap. First, we'll look at the kind of surprising way these GPUs even get made. Then, we'll find out where they actually live inside your phone. After that, we dive into the really cool stuff, the puzzle of power versus performance. We'll see the clever tricks they use to solve it. And we'll wrap up by looking at the new big shot on the block, the Immortalis GPU.
Okay, so let's start with something you might not expect. Who actually makes the GPU in most Android phones? Well, here's the twist. The company that designs almost all of them doesn't actually make a single one, not a single chip. So how does that even work? Well, it's all about a company called ARM. Think of ARM as an architecture firm, but for computer chips. They don't build the house, they design the blueprints. They create these incredibly detailed designs for GPUs, like their Mali and Immortalis series. And then they license or sell those blueprints to companies like MediaTek, Samsung, you name it. Those companies then take the blueprints and actually build them into their final chips, which we call a system on a chip, or SoC. All right, so that's the business model. But that leads to the next question, right? Where does this licensed blueprint actually go? Where does it live inside your phone? Let's zoom in a bit. It ends up on that system on a chip, the SoC. And the SoC is basically your phone's entire brain and nervous system, all packed onto one tiny sliver of silicon. Seriously, it's got the main processor, the CPU, the modem for talking to the network, and right there in the middle of it all is our star for today, the GPU. It's this all-in-one approach that lets our phones be these pocket-sized supercomputers. So let's get into the nitty-gritty. How does this engine room actually paint a picture on your screen? Let's follow a single frame of a game. It all starts with the CPU, the main brain. It figures out the game's logic, where your character is, what they're doing, and creates a to-do list for the GPU. But that list is in a different language. So a piece of software called a driver acts as the translator. It takes the CPU's instructions and turns them into commands the GPU can actually understand. Then the GPU gets to work, executing those commands and drawing the entire image. And finally, a little component called the display controller grabs that finished picture and zaps it to your screen. Now get this whole dance happens 60, 90, even 120 times every single second. That's what gives you that super smooth animation we all love. But doing all of that fast, over and over again, well, that creates a huge problem. And it's really the central challenge for any mobile device. How do you get incredible performance without killing your battery life? It's a constant tug of war.
And here it is, the heart of the problem. The number one enemy of your phone's battery is moving data. Seriously, every time the chip has to reach out to the main system memory, the RAM, it costs a ton of power. It's like having to run across the street to grab a tool every single time you need one, instead of having it right next to you. It's slow, and it's a battery killer. So pretty much every clever trick we're about to talk about is designed to avoid doing that one thing.
And just to give you a sense of scale here, a big, beefy desktop gaming GPU can slurp down hundreds of watts of power. Your phone's GPU? It has to deliver a great experience using less than 5 watts. That's an insanely small power budget. It's the difference between your phone lasting all day or you desperately searching for an outlet by noon. So how on earth do they solve this? How do you draw these beautiful, complex graphics without constantly making that power-hungry trip to RAM? Well, the answer is a really, really clever strategy called tile-based rendering.
The idea behind it is actually pretty simple, but it was a game changer for mobile. Instead of trying to render the entire screen all in one go, you chop it up. You break the big, difficult problem down into hundreds of little, bite-sized pieces.
And this really shows the difference in philosophy. A desktop GPU is all about brute force. It just renders everything at once, constantly going back and forth to that external memory. But a mobile GPU works smarter, not harder. It takes one tiny little tile, say a 16 by 16 pixel square, and focuses only on that. It pulls all the data it needs for just that little square into its own super fast, super efficient on-chip memory. It renders it completely right there, and then, only when it's totally finished, does it write the final pixels back to main memory. This one trick is the main reason you can play a game for hours instead of your phone turning into a hot brick in 5 minutes.
Okay, so tiling is the big one. It's the main strategy. But the obsession with saving power,
Oh, it goes way deeper than that. The engineers have come up with a few more brilliant tricks to squeeze out every last drop of efficiency.
One of my favorites is called AFBC, or ARM Frame Buffer Compression. The best way to think about it is like zipping a file on your computer. Before the GPU sends that finished tile back to main memory, it zips it up using special hardware. It's a lossless compression, so no quality is lost. And by doing this, it can cut the amount of data it has to send by up to half. Less data to move means, you guessed it, less power used. It's just a straight-up win for your battery.
And then there's this other incredibly clever idea, transaction elimination. Basically, the GPU is smart enough to not do work it doesn't have to. Think about it. In a game, maybe there's a big patch of blue sky that doesn't change from one frame to the next. The GPU looks at that tile and says, hey, this is exactly the same as last time. So instead of wasting power to write the same data all over again, it just doesn't. It cancels the transaction. Why waste energy updating something that's identical? This happens all the time, not just with blue skies, but with user interfaces, backgrounds. It saves a surprising amount of power.
So all these tricks are fundamental to how modern mobile GPUs work. But now, let's look at what's happening at the very top end. ARM has a new flagship brand called Immortalis, and it's bringing something to phones that, until recently, was only for high-end PCs.
So for a long time, ARM's GPUs were all under the Mali brand. And Mali is still the workhorse, right? It's great for everyday gaming on most phones. But Immortalis is the new top tier, the premium line for flagship devices. And the one thing that really sets it apart is its killer feature, hardware ray tracing.
Okay, quick sidebar. What even is ray tracing? In the simplest terms, it's a way to create ultra-realistic lighting. For years, games have had to fake things like shadows and reflections with clever tricks. Ray tracing doesn't fake it. It actually simulates how rays of light bounce around in the real world, which gives you these incredibly lifelike and dynamic scenes.
Now, trying to do all that complex light simulation just with software on a phone, it's a nightmare. It would just grind to a halt. So what Immortalis brings to the table is dedicated hardware, a special-purpose ray tracing unit, or RTU. Its only job is to do the super heavy math for ray tracing and do it efficiently. And the result is just massive. We're talking a 300% performance jump over trying to do it in software. This is what's finally making true real-time ray tracing on a phone a reality, without it melting in your hand.
All right, let's wrap this up with the key takeaways. First, remember, ARM designs the blueprints. They don't actually make the chips themselves. Second, for mobile GPUs, it's all about power efficiency. That is job number 1, 2, and 3. And the main way they do that is by avoiding that slow, power-hungry external RAM as much as possible. They use clever tricks to do this, like tiling, compressing data with AFBC, and skipping unnecessary work with transaction elimination. And finally, the new Immortalis GPUs are bringing hardware ray tracing to flagship phones, which is a huge leap forward for mobile graphics.
And all of this leaves us with a really interesting question to think about. Mobile games are getting insanely complex, right? They're starting to look like stuff you'd see on a PS5 or an Xbox. But that demands even more performance. The power budget, though, that's not really changing. The challenge is the same as it's always been. How do you deliver that next-gen experience without your battery dying in an hour? So I'll leave you with this. Where do you think the next big power-saving trick is going to come from?